Hello guys, my name is Satyat Raghuvanshi and this is the first lecture of the NumPy series where you're all gonna learn about the basics of NumPy. If you're a beginner to NumPy, then sure you can watch this series and you're gonna learn many things about NumPy, that what is NumPy, where NumPy is used, and all the codings and all the functions, inbuilt functions used in NumPy. So let's get started. So before NumPy, I want to tell about what are arrays. Like if you are new to NumPy, and so you must have a prior knowledge of arrays, which will make a very easy for you to understand NumPy. So arrays basically basically a collection of data. The data can be heterogeneous or the homogeneous data, but in this case for the NumPy, the array, the data will be the homogeneous data, means the similar data, and they are stored in arrays in the form of like you can say numbers. Like in NumPy, the data are stored in the form of numbers. So yeah guys, that's a basic, or it's very basic information about arrays. And to know more about the arrays, you can just type the array on Google, and you can see many links. You can just open the first link, introduction to arrays, on the Geeks for Geeks, and you can just learn more about the arrays. You'll get many functions, you'll get many links here, and you can see more about the arrays. So let's continue with our NumPy. So basically, NumPy is a very powerful library which is used to handle data in the form of numbers, and NumPy basically crunches and handles data in multiple forms. Like there are many inbuilt functions in the NumPy which helps us to handle the data and the numbers in many ways. So NumPy basically it is written in C and C++ and Fortran codes. So that's where the NumPy is also faster than the traditional for loops and the loops used in Python. So and it uses also a concept called SIMD. The form is a single instruction and single instruction multiple data, in which this parallelism, it is a concept of parallelism where multiple data are handled parallelly or simultaneously. That's why NumPy is basically faster. So I'll just read out the definition. NumPy is a library for the Python programming, adding support for large multidimensional arrays and matrices, along with a large collection of high-level mathematical function to operate on these arrays. So yeah, that's the Wikipedia definition for the NumPy. So let's get started with the NumPy series and let's handle all the data. So before this guys, if you are using the default Python IDE, Python IDE, so you have to just open the terminal window like the command prompt, and you can just install NumPy by just saying pip install NumPy. So that's the command for it. And if you're using the Anaconda IDE or the Jupyter IDE like I'm using it, so you can just open the Anaconda prompt, and you have to type the command conda install NumPy. So that's the command for it, for installing the NumPy in the Anaconda environment. So I have already installed the NumPy. So let's get started with the NumPy. So first of all, we have to import the NumPy in our programming. So we'll import NumPy as np. Let me just zoom it in a little bit. Yep. So yeah, sorry guys. So this is the importing command for the NumPy. So import NumPy as np. So what is as np? As np is basically alias. Like basically we are saying that we are importing NumPy and we are giving a secondary name or the short name known as NP. So you can give any name like AS, AABB, anything you can give. But but most in a traditional way, it is good if you use NP as a alias. So after running it, yes, NumPy is imported successfully in our programming. So yeah, let me just guys, yeah, so we'll first of all we'll define a list in the Python. So we'll say 1 2 3 4 and 5. So we have just declared a list. In the list, if you'll check the data type of this list, for just ensuring what's the data type, so it will show yes, it is a list. The thing we have declared here, it is a list. So this is the function you can use, type, and in the brackets you can just give the variable name. So now guys, if we have to convert this given list into the NumPy, into an array, so how do we convert it? So basically we have to just declare an array, a variable known as array, and we'll say NP. NP means the alias, we are calling the NumPy here, and NumPy dot we'll say array, and we'll just do list 1. So we are saying, hey NP, convert this list into an array. So if I run this command, yes, it has successfully converted the given list into an array. So now if we'll check the data type, we'll get something like this. So now guys, if you will just print the array, the newly array, you will see that there's a array formed and we have successfully converted the initial list into a new array. So now guys, I just want to, there's one important thing, that how can you say that this is an array or not? So basically if you see that this thing, there's only one open bracket and then there's only one closing bracket here, which tells us yes, the given array is a single dimensional array. So just to make sure that this is a single dimensional array, there is one more function called shape. So we'll use that function shape, and we'll see that there are 5 elements present here. So if the array is a single dimensional array, so in the shape output we'll get only the number of elements present over here. Otherwise, if it's not a single dimension, basically shape tells us how many rows and how many columns are present in an array. So as it is a single dimensional array, so this one the shape function will only tell us how many number of elements are present over here. So yeah, that's it about guys, and this was the basics of array, the starting of array. In the next video we'll study more about the arrays, like the multi-dimensional array, and in the further videos we'll cover more important topics like indexing and how to retrieve elements from the array. Till then, goodbye and take care. If you like this video, please like the video and please share it, and please subscribe to Code Initiative. Thank you. Goodbye.